Yay, just decided to change the music completely on a whim, but it's still Mario Picross. Welcome, hi. There's not really any of you here, is there? I'm sure that'll change. Not like that's ever stopped me before. Yeah, I'm gonna be making, continuing on the game that I was, last time. I think it was the day before yesterday. I'm trying to stream more often, as you can tell. Yeah. If you're wondering, since I mentioned it, the music is from Mario Picross. It's nice. It's chill music. The one for the SNES. It's good music for this kind of thing, I feel. What I used to have before was like Professor Layton music. Puzzle game music lends itself well to this kind of task, I feel. Because, you know, programming a lot of times feels like a puzzle, so I guess it makes sense, right? Right, here we are. So what we did last time was handle the movement of the player, managing to get the player to move along a curve and making sure that that works fine, right? Making sure that the movement doesn't glitch anymore. We basically fixed all of that. We also fixed the bug when it came to retaining velocity upon wall collisions, which shouldn't happen. When you collide with a wall, that like if that makes the player stop, then it shouldn't carry over the velocity from their run. So we fixed that as well. So that's pretty much us done with the basic movement of the player, and now what we would want to do is, what I put in this to-do list right here, have stuff for the player to interact with, because if the player is the only thing moving, then it doesn't really, it's not good, is it? So, in order for the player to interact with stuff, it has to be able to collide with it, but actually, maybe even before that, you probably need the stuff that the player can interact with, the stuff that is objects in the game, to be able to follow the same curve that the path is following, that the player is following, right? Because if that can't be done, then you know, like if you want them to just live in the same space, or to be capable of living in the same space. This probably means that some of these scripts will have to be modified in order to be generic, rather than being specifically working with the player. The good thing is that I already have made some advancement in that just by keeping this path snapper node as a separate node from the movement handler. That means, in theory, that I should be able to separate them easier, but I expect that it's still not going to be a very clean separation. We'll see, right? So that means that finally we get to have a third scene in here, right, don't we? Let's have this be... Let's see, what should we do? What do I want to do? Well... let's say just a little box, right? Just a box that the player can push. That will be the first interactable thing, right? And that'll probably serve to let us create the baseline for all the stuff that follows a curve should have, right? So let's create this folder. Let's say box. Just a box. It's a box, and all that has to happen is that the player has to be able to push it. That's all we care about, right? So, how would we handle this? Well, first we're gonna need a scene. And this should be a 3D node. And like, it should probably be the same type as the player. It should probably be a character body 3D, right? I think. Should it have like actual physics? I don't think I like that, no, because it's gonna be moving along a spline, and I want to have like a lot of control over that. I don't think it's a good idea to have like actual physics for this kind of thing. Right? Because here's the issue. I figured that if it has actual physics, then I'd have to bend those over the path, and I'm not sure. I feel like that's gonna be like too much of a hassle, right? Let me think about this actually, because this is not a trivial thing to decide. Uh, hmm. Hmm. Right. If it follows physics, like if it goes along with Godot's physics system, like I'm trying to think of how I would handle it, right? Actually, before that, I should probably Google, like, can I mix and match? Like, can I have a character, uh, you know, whatchamacallit, a character body 3D? Can I have that interact with like a physics-based thing? Is that even allowed? Hmm. Uh, okay, this seems like it's a pain in the ass, actually. I'm reading on how this is usually handled. Hmm. Yeah, the problem is that if I make it a rigid body, that might make things a bit messy here. Give me 1 second. Yeah, how do I handle this? This is I don't think I want to make it a rigid body. I really don't think so. I think that would be mostly a bad idea, right? So it should have to be a character body, but then it would have to be moved by external pressure, right? Like, yeah, the movement handler would have to... The movement handler would have to be aware of the things that it is pushing against. And if they belong to certain groups, then be able to do things to them, right? Like, push them. Oh, this is actually a more complicated issue than I thought it would be. Okay, then maybe I don't want a box that is pushed to that first. Maybe the first thing I would want to do is make something that... Make something that just moves on its own, right? Because that mimics the functionality that the player already has, so I know it'll be similar. And then I can do that first and then worry about how to make things react to players pushing them. Yeah. So yeah, okay, that's what I'm gonna do. I'm gonna make a little guy that moves back and forth, and that's all we're gonna be doing. So then, let's just not worry too much about what this guy is going to look like. This is just going to be another... Actually, let's make it just like the player. It's going to be another flat guy. So we're going to just have a collision shape. That's going to be a box. 3D. And so let's not call it box in that case. In that case, let's call it... just sliding guy, right? Back and forth enemy. Let's just call it Goomba. It's not obviously going to be a Goomba, but Goomba is a name that explains well enough what this guy's behavior is gonna be like. Goomba. Now we have a collision shape, and this collision shape is going to be a box, and it's going to be 1 meter by 1 meter by 1 meter. What's the player's collision shape actually? Like, what's its size? It's 1 by 1 by 1. But the skill of the player is 1. Okay, so it all works out. I have this Goomba thing, and we have to... Right, so this guy has to be then a character controller then. Character body, yes. Right, and then we need to be able to see this thing. So let's just have it work the exact same way that the player works. It's gonna be a sprite 3D. Like this, and we're gonna give it a texture, and the texture doesn't matter, it's just something so that I can see it. So gradient texture is going to be... Since I called it Goomba, let's make it Goomba colors. Like that, right? So then, what does this guy actually move like? Well, to begin with, the sprite should fill that entire space. So let's give it the same scale that we gave it on the player and make it 1.5, I think. It's close enough. Hold on, what? Oh. Oh, okay. Yeah, no, I was just confused by the perspective at some point. Okay. So then this guy is going to just move back and forth, right? So I wonder if I can reuse the movement parameters here. Right? Like, this is a maximum horizontal speed, ground acceleration, air acceleration. These are like player parameters, but I could give them to the guys, right? And just have them just not use all of them, right? And like they'll still use the max horizontal speed and stuff like that, and like, because the idea is that if I have something like ice, I want these guys to be able to react to being on ice as well, to have their physics be sort of different, right? And ideally, they should be different in the exact same way, or it should feel like the same way as the players are different. So like if these guys, if the player has a max speed of 80, these guys have a max speed that is a factor of 80, right? Let's say that I will do that. Okay, so these guys, since this is going to work similar to the player, these guys are going to have a movement handler. However, they are not going to be using an input processor because the movement handler just works on a predictable movement. So instead of an input processor, they're going to have movement behavior, right? So basically a node that is going to tell them, hey, you move left, and then you move right, and then you move left, and then you move right, right? So yeah, so then these are going to have a node that is going to be just a node, because all it is, it's a host for my code. So, so this node, right? This is going to be the thing that it's the decide. So it should be their brain, right? The brain is not really a good way to put it. Yeah, how about something like work decider, right? Or something like that. Work direction decider. And it's a bit verbose, but it works for me. So then what this guy does is we add a script to this. We put it in here. No, not either. In here. Right? And then close all the others. Right, so this one works very simply, right? It's going to have a timer. And it's going to be like, Yeah. Switch direction timer, and so it's going to have just a couple parameters, and they're going to be like, well, first of all, of direction decider, right? And so it's going to have just two parameters. A start direction, which is going to be a boolean. Actually, we probably want a bit more than that. We probably want this to be readable. So let's make it an enum. Let's add a new enum to our enums script. Right? This is easy. It's just enum direction, and it's going to be forward or backward. Right? Forward or backward, right? And the reason for not calling them left or right, and also let me move this comment because it should be here, is that they are forward or backward along a curve, right? Since the movement is along a path, since the movement is going to be based around curves in the 3D space, right? So whether you're facing along the direction of the path or against it, and that could mean many different directions depending on how exactly the path is twisted, right? So that's the idea. And then we are going to take the one direction that is going to be one of those. So it's going to be enum direction. And actually, we could make this a bit better explained. Let's call it path direction, right? And then here, enums path direction, like that. And so this can be one of either forward or backward. And that is just the starting one. It's going to switch every time this timer runs out, which is going to be enabled here. So export var time to switch direction, and then it's going to be float. So then when this script starts, so function on ready, you are going to, we probably want to export also the name of the timer. So export var timer node, it's of type timer. And then we gotta give it, so let's make it 1 second just to test. Start direction forward. Pass. We assign the timer right here. And then when we are ready to begin, what you're going to go is you're gonna take the timer node. You're gonna tell it to start, and you're gonna tell it that the time is the time to switch directions. That's how that one works, right? the wait time. Yeah, okay. And then this is going to be not auto start because it's going to be started by this, but it's going to be not a one shot, so it has to loop. So every time it finishes, it's going to start right up again, right? And that makes it so that it's going to be switching every 1 second. Then, whenever this timer expires, so on a signal from this timer, you're going to react to that happening by switching the time to switch direction. By switching the direction. Actually, we need to have that as a variable. Current direction would be enums point path direction. That's the type of it. And then, yeah, current direction going to be equal to that start direction. Then every time the timer expires, you're going to switch the direction. So current direction equals, well, that depends actually, yeah. If current direction equals enums point path direction point forward, you make it backward, else if the direction is the opposite, and yes, there is a reason why we're checking this. It's just so that we can be sure that the direction is a valid direction to begin with, because if it's not, then something's gone wrong, right? Forward switches to backward, backward switches to forward. And then if it's neither, then we're gonna throw an error. Right? Like that. Yeah, that should work. And so, yeah, and so we have a thing that is going to switch direction every, well, 1 second in this case, but you can set it up here. You can change it. It's fine, right? These values should probably be propagated from the Goomba so that we can set them per level, right? But let's, yeah. Let's do this way. Let's actually make this with a couple more helper functions, because I want this stuff to be able to react nicely to the Goomba's initialization, passing those values even though they are not going to be necessarily happening before this function begins, right? So let's create a couple functions to help you with that. So first, let's do a function that just explicitly switches directions. And that is going to be this. So then when the timer dies, then we call that function. And that allows us to switch current direction under other circumstances without having to copy and paste to copy the code. Then we're going to write another function that is going to be start movement. And that is going to be in charge of doing this stuff. So starting the timer and then changing the current direction to be that direction, right? Then the ready function calls that. The idea is that if at any point after the ready function happens, you get another set of timer or start direction, then you can call this function and just have all of that happen, right? So then we would have this. When the start direction is set to a value, what you're going to do is change the value of start direction to that value, like make sure you properly store it, and then call start movement. And then the same is going to be true for the time to switch directions. If either of these are changed during execution, then you're going to do the start thing again. So if somebody tells you, oh, now you move a different time, you're going to start the movement again, right? Which shouldn't happen very often, but if this ready happens before this ready, it makes it so that things don't break or the thing doesn't move unexpectedly, right? So with that done, I can make it so that this Goomba actually has a script that feeds those values into this. So, and that means that I should probably make sure that these aren't exported then. They're just values that you will expect to get. No, the timer does go. I do want to set that in here. So actually, let's put that here just for it to be more orderly. And there we go. So then this Goomba, we need to add a script to it. That's just going to be called Goomba, because why not? Oh, give me 1 second. I gotta handle something real quick. Okay, so it should be done. Yeah. Okay, so we have a little Goomba thing. We are making a new script for it. We're gonna call it Goomba, but you know. So. Right. So this guy is of type Goomba now, right? We're deciding that that's the name of this type. Then we want to pass these values onto it. So we want to give it to it. So export start variable start direction, and it's going to be of type enums path direction. Going to have another one that is export time to switch direction. This is going to be a float, And so these are going to be just forward and 1 second. And then on ready, the first thing that you're going to do as soon as you begin to exist is take this start direction and pass it to that guy. So export var walk direction decider is of type walk Goomba walk direction decider, right? And then yeah, since that's exported, I have to give you it right here. And then on ready, the first thing that you're going to do is take your start direction, rather take this decider and tell it, hey, your start direction should be the one that I have, and your time to switch direction should also be the one that I have. Like that, right? And then you should be able to give. There is one problem in this: is executing this ready function, or rather the start movement function is executing it twice, which is a bit unnecessary, but that's not going to be an issue. It's a short function anyways, and there's not going to be a billion Goombas on screen anyway, so so having had those values, right, so those values, so this guy is keeping track of those values. It knows when it should be walking left and when it should be walking right, but it's not yet doing anything with that, right? Is it? So we need another node that is going to be its movement handler, right? We add a node, just a normal node. This is going to be the movement handler. And so this movement handler is going to have a script, and this script is going to be a new script because we can't reuse the player movement handler. The player movement handler does way too much shit that we don't actually care about. We actually wanted the movement of this guy to be way simpler. So let's just call it movement handler, because I'll know it will be different just by the fact that it is in the Goomba, right? So movement handler. And so this will be class name Goomba movement handler. It extends a node class. So the first thing it should do, just like the player movement handler, in fact, a lot of this is going to be similar to how the player movement handler does it. So we could probably benefit from copying a lot of this and pasting it and then deleting things as necessary, right? Right, so this is the player movement handler script that I have copied, but we're gonna change it to be a Goomba movement handler. Okay. So first of all, rather than an input processor, this one has a direction decider. So Goomba direction, Goomba walk direction decider, right? I probably misspelled it. Yeah, so it has a direction decider, right? It has default parameters. I'm going to be getting those, right? It has a player body. No, it doesn't. Let's just call it body, right? This is the body that it's going to move, which is going to be this one. Then it has a path snapper. It doesn't have it yet. Let's give it to it. In fact, let's copy it from the player because it's probably going to be the same. Yeah, this doesn't do anything that is player specific, so I can probably reuse it, right? I hope that I can reuse it, right? So let's fill in those. So the input processor is not an input processor. Let's save it. Right, and we're gonna have to fix all these errors before it'll let me. Okay, so let's do that later. Current active parameters, which is going to be that. Current horizontal speed and vertical speed. We should we should yeah, we do need a vertical speed. I was just kind of deciding on that. We don't need the fast fall. This guy does not have the capacity for fast fall. This guy just falls. And this guy also doesn't need a jump buffer because this guy doesn't have any input. So those two, gone. Right? The path is given by the player node. Yes, the path follow is also given by the body node. Given by the body node. Right? So yeah, we're gonna have to make that work. So it's the same way that the player does it. So like this, let's just copy this because I know it's going to be basically the same way, and the Goomba is going to do that stuff too. So it's going to receive a path, right? It's going to receive a path follow. Of course. Ooh. Okay, hold on. I'm just realizing something. The implementation that I did for the player with the path follow is not very scalable, because then I have to, like, for manually on my test scene, I have to have a player path follow for each player that I have, which, okay, there's only going to be one player, but then if other things work the same way, then I'm going to have to have one for each, and I'm going to have to create it manually. So if I have 20 Goombas, I have to take all those Goombas and create them, and that doesn't really work. So the way that it should work is that they each instantiate their own path follow. So this thing should be a scene, a packed scene that they all can hold so that they can create one. That should be the way that it works. Let's do that for the Goomba, and then if it works, we'll do that for the player. So yeah, let's do that for the Goomba first and just leave the player like that for now. So this is going to receive a path. It's going to be put onto you when you're created on the scene, right? So yeah. This is written like shit. I'm just ordering code. You have a path. You're going to have a path follow, sure, the movement handler, but except you don't have a movement handler. What you have is a walk direction decider. No, you do have a movement handler as well. You have here. And then on your ready function, you're going to take this movement handler and kindly tell it what the path and the path follow are. Right? So that's the way it works. So the only difference right now is that I want you to create this path follow, not to receive it. So rather than having it like this, you're going to have a path follow scene. This is going to be a packed scene, right? Then on ready, on top of everything else that you're going to do, you're going to instance the path follow, and then that instance thing is what you're going to give to the movement handler, right? So then we have to create that function instance path follow is going to return it's going to return a path follow. Yeah, it has to be the same type, so it has to be a path follow 3, right? This is going to be the thing that is returned, and it's going to be the thing that is instance that is returned. So then what you do is you take that packed scene. Yeah, it has to be a child of that path, because that's how the path follows actually function, right? So you're going to well, first you're going to instance it. So for instanced scene, no, instance node going to be equal to the path follow scene instantiate, right? Then that instance node, you're going to make it the child of the path. So path add child, the instance node. And then you're going to, since the child has been added, you're going to return it. So return the instance node. And then it's going to be like at sort of in working order. Then once it's returned, you can give it to the movement handler for it to work off of it. And then, okay, so we have the node is being passed on. So from here on out, it should be exactly the same as before, right? So then the movement handler, now let's fix this. So you have a path, you receive the path follow, you do everything just sort of the way it should work. Give it to the path snapper, everything. Yep, this works. You start with horizontal and vertical speed both 0, and you set the default parameters. This default parameters just turns the current active parameters into the default parameters. Makes sense. Then the physics process. Okay, so here's where stuff stops working. So yeah, input processor, horizontal input. We don't want this to be this way, do we? Do we want it to just sort of... Actually, it should just snap left and right? I think that's fair to do. So rather than having this, we should have... Right, we could do calculate horizontal velocity, yeah, but instead of input processor horizontal input, you're going to take the walk direction... yeah, it's not called that, is it? It's called the direction decider. Yeah, you're going to take your direction decider, and you're going to take the current direction, right? And that's what we're going to use to calculate the horizontal velocity. So then we're going to have to modify the horizontal velocity to be able to work with that. Current horizontal velocity. Calculate horizontal velocity, yes. It's not going to receive a float, it's going to receive a current direction. And it's going to be horizontal, it's going to be enums point path direction, right? That type of thing. It's going to return as float. So then, rather than, yeah, this is too complicated. This guy is not going to have any acceleration, so we don't actually need this function at all. Yeah, we don't need this function at all. This guy just moves with a set velocity. So then, calculate horizontal velocity is going to do... This is not input number. So this is going to be if current direction equals enums point path direction point forward. If this is forward, then you're going to be one value. If not, then you're going to be another value, right? Actually, let's create a variable. This is the float. If it is forward, then the sign is going to be positive, so it's going to be 1. Else, sign is going to be negative, so it's going to be -1. Right? And so then we are going to be returning. We're going to be returning, yes. We're going to be returning yeah, we want the current active parameters and we want the max horizontal speed, but then we want to multiply it because we don't want the whole thing, we want a fraction of it. So times, let's say, speed factor, right? And then we don't actually need any of this. Target speed, acceleration, yeah, we don't need any of that. So then what is the speed factor? That's going to be a number that we're going to set up, right? So add export var speed factor, and that is how fast the Goomba can move compared to the player, right? We're going to export it here, and then when we're sure that it is working, we're going to have it be given to this by the main node. This allows us to have Goombas of different speed, although we don't necessarily need it. Also, I'm getting too used to calling them Goombas when they're not gonna be Goombas. In fact, it's doubtful that they'll even be in the game. Okay, so we have the horizontal speed handled. What about the vertical speed? The vertical speed is easy because these guys don't jump, so they should just fall, right? Calculating the vertical velocity is just... we don't need the jump input because there's no jump input. There's no upward movement. So then the vertical velocity, calculate vertical velocity is here. If not player body, just body. If the body is on the floor, so you don't need this. If jump button state, jump button state doesn't matter. So if you're on the floor, then just return 0. It's as if you never pressed the button. So if not pressed and no jump buffer, so just return 0. Otherwise, now this is if you press the jump button, so none of these matter to us. Essentially, this controls as a player that never jumps. So if we're already airborne, then vertical acceleration needs to be taken into account. Yeah, so yeah. This one does need acceleration because this should fall with like gravity, which is accelerational. But again, we don't need the jump button state. It doesn't matter. Current vertical speed, terminal velocity, acceleration. Yes, okay. So then how do we get this acceleration from vertical acceleration? You don't care about the jump button. That doesn't exist. This doesn't matter because fast falling doesn't apply to Goombas. If not fast falling and equals just released, we don't care because this is not fast falling. If fast falling, we don't care because just don't. So this actually just returns at you the gravity, doesn't it? Yeah, given that that's the case, let's do away with the useless function and just put the gravity there. That's always going to be the acceleration after all. Delete this. Right? So then, yeah, so then we don't care. That's not a thing that we care about. This should be called body. And then, yeah, we go back to this. yeah, so yeah, we have that handle. Vertical velocity is handled. Update the jump buffer doesn't matter because there's no jump buffer. We don't care. That's not a thing for non-player things. Okay, so this is where, yeah, we take the Y rotation and we get that as the relative forward. We get the horizontal velocity times by timesing the current horizontal speed with the relative forward. That makes sense. Yeah, and it's going to be positive or negative depending on whether we're facing forward and backwards. So that's how we're going to get left or right movement. Let's see. We have the horizontal speed. Yeah, so the horizontal velocity is just working. Then we have the player bodies. It's just the body. The body's velocity is going to be the horizontal velocity, and then the up vector multiplied by the current vertical speed. Yeah, that makes sense. We have the global end position pre-snap is going to be the velocity. No, not like that. Body. The body's velocity times a delta. They shouldn't make a difference. Body. And same here, body. So does this actually make a difference? Yeah, this just gives us. Yeah, this actually works fine. The calculation is exactly the same. So then, yeah, we get the position pre-snap. Then we tell the snapper to snap it. To get the actual end position, then turn that position into the velocity that would get you to that position, and convert it into the velocity. Then move and slide. Then change your rotation according to the path snapper / Y rotation. Get the real velocity and apply it to all of these things so that the thing stops when it hits a wall or whatever. And that should be it. So, So does that just work then? If I place this guy here. Well, to begin with, I kinda can't see it, can I? Oh, look at him, he's so tiny. Okay, what scale is the player? What scale is the player? The player is 10. Okay, so you are going to be 10 as well. Yeah, that's basically the same size. Let's put it here and see what happens. Alright. So this is on who? Okay, first of all. Like this. What actually happened here? Yeah, type nil. So this is in the... What script is this? Goomba. Do you think this path is nil? Oh, yep, yeah, I forgot. I gotta assign a bunch of stuff. So, okay, the path is going to be assigned in the scene. The path also assigned in the scene. Actually, this shouldn't be exported at all. This one is created. This one just shouldn't be. Oh no, it should be. It should be. What am I thinking? Yeah. Okay. So the first thing we have to turn this guy into a packed scene. So follow, right, like that, and then the Goomba is going to be given that. So follow like that. Actually, Not this Goomba, just the Goomba. So this guy, give it this. Starts direction forward, switches direction after 1 second. The decider is that. The movement handler is... It's a Goomba movement handler, not a player movement handler. So, yeah. Like that. The path is assigned per scene, so... Then, the what direction decider has all its parameters. The direction decider, yeah, you know the direction decider is this guy. The default parameters are these. The body is this one, and the path snapper is this one. And your speed factor should be, let's say, 0.5. It moves with half the maximum speed of the player, right? That should actually make it work then. And it didn't. Okay, what happened? Cannot call add child on a null value, and you think instance node is a null value because this to instantiate is that one. What about you? Sorry, what's your... Oh, yeah, no, it's not that. That's the null value. It's path, because I forgot to give this guy the path. I will show you the way. Okay. Yep. Again. Invalid assignment to property or key progress. Why progress? No, it's just path follow. Just that. Oh no, hold on. No, this is the path snapper. Float base subject of type nil. So you're not receiving your path follow, right? Is that what am I reading this right? Yeah, okay. So something here is nailed when it shouldn't be. So is it the path follow? Because it works on the player, so... show me the output. One of them is null. Why is it null? Why is path follow null? Path follow you should receive... How do I do it on the player? No, the player doesn't receive it, so it receives it from the movement handler probably. Path snapper path follow. When you're given the path follow, you give it, okay. For the Goomba, when you're given the path follow, you take the path snapper and give it to it. So is this just not happening? No, it did happen. Okay. So if it is happening, wait, hold on. Is it happening on the player? Yeah, it's happening on the player. Okay, so is it happening on the Goomba then? It is happening on the Goomba. Okay, so then why? Path snapper path follow equals value. Then path follow equals value. Are you dumping it at any point? You're not. Okay, it is happening, but is it actually? Like, is it actually being given the correct value? Like, show me what the value is. it's a path follow 3D. And if it is a path follow 3D, if it is a path follow 3D, and this guy is receiving a path follow 3D, then path follow shouldn't be null here. Path follow. Yeah, why is it null here but not there? Are you using a correct path snapper? Are you passing this to the right guy? You have a path snapper. It should be this one. They should be the same. What's going on? Okay, so are you... They are different. Why are they different? Why are they different? Is one of these the one for the player? Is that what's going on? Yeah, the player also... It should be printed 4 times, basically. 34980, 34980. So the one that's crashing is the one for the player, then. Hold on, what? Why? Why? If I delete... I haven't touched the player. If I delete this Goomba... Oh my god, what the fuck? What the fuck? It was... I didn't touch the player. Did I? I don't think I did. Oh, yeah, it's because I turned this guy into a scene, and so that made it so that delinked the relation. So I just had to say it again. Okay, good to know that that's a thing. Okay, so then the Goomba shouldn't cause any issues. But before that, let me remove these prints so that they won't start clogging shit. And then on the player. Yep. Okay. And clean all this. So does the player just work then? Yeah, what was that? There's some sort of bug relating to having the movement keys pressed before the game loads, so that's gonna have to be fixed. But that doesn't seem to be an issue though right now for what we're doing right now. Okay, so let's see if the Goomba even moves, right? This Goomba thing, put it here and make it scale up to 10 and move it up like here. Yeah, and make sure that the Goomba in the scene that we just put in has a path to follow. Moves left, moves right, moves left, moves right, along the curve. Absolutely no problem. Yeah, they just sort of bump into each other, but other than that, that is fine. Ooh, what the fuck was that? Oh, that shouldn't be like that. Oh, when it switches direction, it just sort of flings him. Why is that? It only happens if I am moving. Okay, well, that's just physics bullshit, right? Obviously, but right now the movement works, and that means that the system for creating a thing, path follower, sort of works, right? So that means that the player should be changed to work within that system, right? Just to keep things consistent. So first of all, we eliminate this. We do not care for it. Then the player has to work the same way that the Goomba does. So we have to take the player and tell it, hey, rather than having a path follow, you're going to have a path follow scene like this. And then part of your job is going to be to instance that scene like this. And then the path follow is going to be what you instance from that. And the path follow scene has to be this one. Yep, it just works exactly the same. Okay, excellent. That means that our path following system is actually fairly robust. Like, it means that I can reuse it for a bunch of for basically any entity that needs to exist in the game plane, right? So it's good to know that that works. We still haven't done our to-do, but honestly, knowing that this works, I feel like it's enough for me today. So we're gonna keep that on the to-do list, and we're gonna add something to it for me to work on next time. That is going to be what could it be actually? Camera movement. We need the camera to be able to follow along the path, don't we? And to follow the player, to be able to follow the player, but to curve along the path in a way that makes sense, right? The camera should logically be, unless we choose to override it, always perpendicular to the path, right? So, because that way it's just sort of following the player and the directions of left and right make sense. Not like this where it's still, right? Like if I'm moving here, then right, when I press right on the keyboard, is moving left, because it is right from the perspective of the path. It is forward along the path because I twisted a full 180 degrees. And so we have to make sure that that is not a problem. And so the way to do that is just to make sure that the camera can follow the path. We also need it to be overridden easily in case we want to do like some sort of set piece or something where camera placement is sort of important, right? But that'll be for next time. Because I'm actually pretty happy with the progress I made today, even though it only took me like an hour. Yeah. Yeah. So I wanted to do something else this stream. I want to play more Dynasty Warriors. So. Yeah, I'm gonna be right back. Gotta do some stuff, and then I'll get right back on and do that. Be back soon.